Hello, everyone. Thanks for being here today. I am here with Corey Huck, who is the head of biologicals at Syngenta. He's a last-minute emergency addition to this panel, so he doesn't have his headshot up. Yeah. And Ruth Wagner, who is the vice president and head of data science and analytics at Bayer. And I'm Nadia Berenstein. I'm a writer and a historian of science. So let's dive right in. This panel is about the future of plants, but to be clear, when we're talking about the future of plants, we're talking about the future of life, and especially our life on Earth. Plants' problems tend to be our problems too. And so I'd like to begin by asking both of you, some examples of how we're working with plants to solve and address some of the major challenges that are facing human life as well as plant life.
Yeah.
Right. I'll start since he's going to collect his thoughts. Thank you for joining me, by the way.
You're welcome.
I said I'm not going to do a one-on-one interview, so I almost ran out the door. So thanks for joining us.
Happy to be here.
It's great to be on stage with one of our fiercest competitors, too. All right. So yeah, it's good, right? We need someone from Corteva over here, too. Anyway, I'll answer the question. So I think one of the biggest challenges that we face, and it's been brought up already today, is climate. And while agriculture is a major contributor towards, gas emissions and things like that, the nice part is, as an industry, we can also use farming practices and science and technology to address that issue. And I like that because it's taking, it's responsibility, and it's something we care a lot about is the land and the health of the soil and the future of the planet and ability to feed people is super important. So there are different farming practices, things like special carbon initiatives where farmers can change their practices, things like no-till, things like special cover crops, especially ones that can capture carbon, are things that farmers can do and be incentivized by. In addition, we can have technologies, I'm going to move this over a little, technologies that we develop in the sciences, so things like Megali talked about microbials and biologics, which you can talk about, but also genetics approaches to producing plants that do a better job of reducing the climate impact that we have in agriculture.
Can you, Ruth, really quickly, can you give some examples of how the genetics of plants are being enhanced to make them more resilient to climate challenges or to growth challenges?
Sure. Some of the nice examples are on drought tolerance and withstanding floods. Things like floods for rice agriculture are huge issues. Droughts are becoming bigger issues in many places in the world. So for genetic traits that can help the plants survive through those situations. Another one that Bayer is really proud of right now is our Preceon system, and this is short stature corn. And this corn is growing several feet shorter than traditional corn. And what that allows growers to do is go through the field and apply chemistries, for example, pesticides, exactly when they're needed and not just when the tractors can get over the corn, because once it's too tall, they can't drive those tractors through. So being able to do things like adjust the plant architecture to make it easier for farmers to go through when they need to helps this as well.
So helping plants so that they can, so changing plants so that we can help them. Yes. Now, Corey, I know that your work is focused more on soil.
Yep. Yeah, so I'll start with the original question around plants and why are plants so important. Frankly, none of us would be sitting here today if it wasn't for a plant. Everybody touched a plant or a derivative of a plant sometime today. So I had the opportunity to grow up on a farm in Nebraska, and the way that we manage plants, crops, and everything that competed with them then versus now is substantially different and continuing to change for all the things that Ruth just mentioned, mostly around climate change, continue to be a really big, I can see it on our own farm, and I've had the opportunity to travel just in India a few weeks ago and really see the impact of the climate change on farming and what it means to produce a crop. So the need for technology in plants and the need to help plants become more resilient is really at the heart of what we try to do, and something that I've spent most of my life doing. So yeah, I think there's a lot of really great opportunities to really unlock the science of plants. And to your point you just made in terms of soil health, we've always really looked at the plant itself, but there's really a deeper symbiotic relationship between the microbiome and the plant roots, and the way they speak to each other and the way they depend and the interdependencies of each other. So there's a lot of science really to unlock to understanding that and how we make plants more resilient.
Yeah, in our conversation before this panel, you described it in a way, it was sort of like the difference between medicine that treats only the symptoms and a medical approach that looks at the conditions that allow the whole organism to thrive and flourish. So I think.
Yeah, that's really something that has been really a change in our organization, I think across our industry as a whole, is we were very biotic stressed, managed and focused in the past. Symptoms. You have an insect, you have a fungus, you have a weed competing with a crop, let's try to take care of that. And we're taking a step back and saying there's maybe a little more to think about here. Is a more resilient plant, a healthier plant, could potentially help stave off some of those stresses. So I lead the biologicals group, and that's really what we're doing, is looking at plant biostimulants, nutrient use efficiency, a lot of the technologies that Ruth mentioned, as well as if that plant is healthier and off to a better start, it will have a better chance at, first of all, finding its full potential, and second of all, fighting off all the challenges, whether it be climate change and everything else that's coming after it. A more resilient plant is really what we're after at the end of the day.
Maybe, can I add to that?
Yeah.
My technical background in the sciences around data is on omics and being able to collect all of that, and I've just been really impressed, and it's sometimes also overwhelming in the last several years about how much data are out there that you can collect and try and process and interpret and gain knowledge from. And so when you think about all of the data from the plant itself, its metabolome, its genes that are expressing, its DNA, the proteins that are all in there, on top of that, everything else that's going on in the environment, where we have plant sensors and satellite imagery, all of this information coming in really helps us, I think, address the whole plant itself, and also in the context of the environment that it's growing in or is expected to be grown in.
So how does this flood of data that is always, and that always seems to be increasing, how does that shape your research? And how does that guide the new, or sort of reshape the horizons of the possible for what you're doing at Bayer?
That's a great question, and this is something that's not just a Bayer issue. It's true for, I would say, other companies, other industries, and academic research, as well as being able to make sense of all of the information that's out there and know what information and what data are relevant for the question that you're trying to ask, and ensuring that you have that. And so there's this balance of collect as much information as you can about everything, but also needing to be able to understand that data, have high quality data, and make decisions based on it. So from my team's standpoint, I mean, it's great. It's our job to be able to collect, ingest, process, and make insightful decisions based on it. But also, being able to store it and keep it and understand it for a long period of time. There's a lot of, I would say, stewardship things that come up, which is a totally different topic than today, but that's something we have to be mindful of.
Corey, how does your team or your group identify the problems that need to be solved? How do you sort of direct your energy and your research?
How do we direct the research? Yeah, this is an area where predominantly been synthetic chemistry in the past, and then now obviously through collaborations with Ginkgo and with others, how do we expand our portfolio of technologies that we think might be beneficial to farmers? And picking up off of the technology and the data piece of this is absolutely critical. I think we have over 200 million acres annually that we collect data from all the way at the farm level globally. And that insight and that data can tie back into the type of data that Ruth just mentioned at the very scientific and research level. And what's really, as you get more data, you get more intelligence. And what we're finding is we can produce and build and identify better and discover better products, more effective. And one of the elements that we really spend a lot of time on is thinking about sustainability and what's the regenerative approach of that product, how can it work, and then have all the data to support it. And another element that we're looking deeper into is soil science. Soil's been around longer than life itself, and the amount of information and knowledge we actually know about the science of soil and the microbiome and the interaction of that microbiome is still a relatively infancy in terms of the scientific understanding of it. So understanding this data, uncovering it, and creating and driving towards new discovery and using different modes of action. We use a lot, we're really looking at a lot more natural places like what Millie just shared in terms of microbials. We'll also look at fine chemicals and even biofermentation for pheromones. So there's a lot of really new interesting technologies that are being unlocked by synthetic biology that are really helping us in treating plants more effectively.
Right. I think that one of the things that agriculture and life on Earth really is facing is the long-term effects of chemical fertilizers, farming practices that are overly reliant on chemical fertilizers and pesticides, and thus kind of leach the soil or deplete the soil. So how do the new approaches to thinking about plant well-being and plant futures kind of deal with or address these kind of legacy problems of chemical fertilizers?
I would say there's a wealth of research going on right now in carbon sequestration and understanding how we can leverage plants for this. I even saw an article yesterday, and it was on sheep's wool and how you can process things differently and do this in a more green way. So it's not just in the plants, but also in animal and other efforts, like you said, synthetic. Some examples I mentioned earlier there are cover crops out there. We have an example cover cress that is a gene-edited pennycress product that's we're in pilot launches now, and this is one that farmers can rotate between their soy and their crop fields, and it will grow. It will give them additional money. It is expected to be a great source, alternative biodiesel, and on top of it can sequester carbon. So there are some things like that specific to the carbon capture market.
Yeah, I might be a little more dramatic. There's 800 million people in this world that wake up hungry every day or affected by hunger. That's up 150 million from pre-pandemic. And we're not going to have more land. We're not going to bring more land into production. So degraded soils are one of the most important things that we need to deal with if we're going to feed a growing population that's going to be headed towards 9 billion very quickly. So I don't think we have a choice. We must do something about overcoming degradation of soil and how we make plants more resilient to all that. And I think, fortunately, technologies generally and innovation is usually the answer to that, and you can see that starting to emerge. But I really see it in the nutrient use efficiency type of technologies where everything from endophytes that fix their own nitrogen in the plant all the way to how do you utilize the existing nutrients, whether they be macro or micronutrients in the soil, to make them more available for plants. So science is unlocking this, and we're learning more about how it's all coming together, but the clock is ticking against us, and we need more science, we need more innovation and adoption. And soil degradation, I can tell you, where we're at here in Boston and we're here in the US, it's certainly there's some room to improve, but globally it is really a super epidemic in some of the areas that a lot of work to do.
So this all sounds great. So what's standing in the way? Why aren't more farmers planting cover crops, as you mentioned, Ruth? Or why aren't more regions, more countries looking into solutions like the ones that you've described? What are the roadblocks, both scientific questions that we have yet to answer and social and political ones?
I would say I don't think anybody cares more about soil and soil health than the farmers do. It's their livelihood, it's what they're passing on to the next generations, and so I don't think that there has ever been, you know, some idea of I want to destroy the soil or ruin things, and so as technologies become available, it's important that, you know, they do want to adopt them, and they do. I think there's a couple limiting factors. One would be financial. I'm not going to get into that too much except to say a farm is also a business. And so some of these programs where there's incentivization to do this is really helpful, where they can do work that protects the soil better and it brings more money into their pockets and makes their business more successful is really important. But the other piece is the technology availability. A lot of farmers, farming is done in rural areas, and there isn't the same kind of infrastructure that you see here in a city for, you know, equipment and technology to get there, and, you know, reliable high-speed internet to pass information along. I think that a lot of these technologies that are out there would be better used if they had better infrastructure and access to it.
Yeah, not much to add. I entirely agree with everything that Ruth said. There's one of the biggest challenges is education, getting the innovation on the farm. There's over 680 million farmers globally. And to try to get your technology or get a new technology that might affect soil health or affect plant resilience to that many farmers, it's not like going to a hospital system where you can just push it out quickly. It is a very heavy infrastructure-oriented business that we're in.
Right. How do you make this appealing and viable for smallholder farmers, especially in, you know, on the African continent, in South Asia? What are the, like, how do we make this actually a viable option for people who are farming, you know, who are doing most of the farming in a lot of the world, actually?
Yeah, I can start. 3 weeks ago, I had the chance to be in India and met with our local team, and we have a team that are out talking to farmers every day. Not enough of them, but we're talking to farmers. And what really got me is I sat down and spoke to a lot of these growers. And since you're starting at such a low production base, when you would speak to them, you would ask, well, what impact did our products have on your farm? And the minimum amount was 30% increase in output and yield, and up to twice as much. So I said, well, what does that mean to you? Well, you know, he's like, that's the difference between my son having to stay home on the farm and not get an education versus having enough production that I can sell enough off and send my son off to be educated. So it's absolutely fundamental, and I think that's really the key of how do we get those technologies, because once the adoption happens, once they see the impact that it can have, it helps the socioeconomic system as well. So reaching them is really, really, really difficult.
Maybe I agree with all that, and one thing I would add on is, and some of this is within some of our control, and me personally, it feels sometimes a little bit out of my control, but I would say things like the regulatory landscape, it's very complex, and so for a company to spend, you know, 10 years and hundreds of millions of dollars developing a product to get it out there in a way that is affordable for all farmers, it doesn't have to be expensive, but they have to be able to access it. And so even if we can develop a technology, if because of regulatory or infrastructure it can't get to that region, we have a problem there. And so, you know, in a dream world, a simplified regulatory landscape would be helpful for getting technologies to everybody who wants to use them.
So Ruth, changing tacks a little bit. As a historian of science, one of the things that you see is over history is when disparate areas of knowledge converge, you often see these kinds of explosions of research and generativity in new scientific fields. As somebody who was trained in plant biology and now finds yourself in data science, can you speak a little bit about how these two fields are kind of converging and what that makes possible?
Yeah, that's a good question, and earlier when Nadia told me about this one, I was excited because I told her the way she wrote it kind of read like my career of talking about all these kinds of data and how do you put them together and how do you do something with it, and then connecting that with modern analytics today. And so for me, it's been really fun watching organizations like mine and like other data science groups move from being seen as a service to actually driving innovation and product opportunities. So there's one way we look at it at Bayer is this spectrum of digital transformation, and on one end of it you have basic process automation. So how do you take an existing process and automate it? And that's great, but it requires somebody to tell you this is how we do it, and then you automate it. And as you get more mature on that spectrum, you can start to do things like come up with new product concepts that can help. Related to precision agriculture, some things we can think about, the teams earlier were talking about AlphaFold and predicting protein structures, and the new waves of that with OpenFold really pushing that technology, but also things like when you think about promoters and optimizing gene expression, getting a plant to express the protein you want to see in the exact tissue at the exact time is something that can't be done without these kinds of sophisticated analytics and nominations into our pipeline. And so I get really excited when we can actually look at a product in our pipeline and say we couldn't have done that without the data science, we couldn't have done that without the AI, and that's something I look forward to continuing to see in the future.
So it seems like the scale of data collected properly used can sort of contribute to both the speed of innovation, shape and guide research and work, and also lead to a kind of increased precision of results. Corey, to kind of finish us off, do you think, can you speak to the ways in which the increased precision that's available now is shaping the dynamics of this field?
Yeah, it's certainly having a huge impact, and I think Ruth really picked up some important pieces of bringing digital through the entire system, all the way from discovery to the use on farm, and making better decisions, which will drive better products. So I'll use a couple examples of where we see precision having a big impact. We launched a product last year in Indonesia called Nalvium, and what it does is it's a biofermented pheromone. So instead of using a lot of applications of synthetic insecticide to control rice stem borer, we put out the pheromone that is disrupting the mating habits basically of the rice stem borer, so they go elsewhere and procreate, therefore reducing over by half the amount of synthetic chemical that's needed. So the precision of that is really understanding, how do you apply it, in what ways do you apply it, put the data analytics over top of that, and assure that you have the right product in the right place at the right time. And then in microbials, for example, there's a lot of opportunity. I think we're just starting to understand, and I keep going back to the soil because I really think the soil can uncover a lot of the capabilities and a lot of the plant resilient issues that we currently have today, and climate change is only going to bring more upon us. So I think the idea is how do we actually use data to create better products. We can start to see early signs of it, but there's still a long ways to go.
Any thoughts on the sort of precision that's allowed by that's being made possible by data, Ruth? We have only a minute left, so.
I think I covered a lot of it. Maybe just saying, the ability, I've talked before about the insights and tracking these decisions. I think that's the most important piece. A lot of people here who work with data or any pipeline know the phrase garbage in, garbage out, and we really need to be able to avoid that situation and not get overwhelmed with the amount of information. And this is where subject matter experts are always needed, and some people worry about can the computers just do it all and the algorithms do it all, and really you always need people to look it over. This is true right now with ChatGPT being out there. It can give you wrong answers, and you have to have people who can decipher and distinguish a good answer from a bad answer. So we still have a long way to go, but it's nice to still have that connection to the data and information.
Fantastic. Well, I think on that optimistic note, we'll end this discussion about the future of plants and our own futures. And thank you all for listening, and thank you both for participating. This is great.
Thanks, Nadia. Thank you.